Welcome back, guys. For today's video tutorial, I'm going to have a look over a sensor that is LSM330. To gain more knowledge about this sensor, let's have a look over the website, and that's controleverything.com, and have a search for this sensor and you can see more about this. So let's see what we got. So we got that LSM330 is iNEMO Inertial Module, 3D Accelerometer 3D Gyroscope I2C Mini Module, and these are some of its features as you can notice on my screen. You can also purchase this sensor from this very site. Now I will be interfacing the sensor LSM330 with a particle photon, and I will be requiring a particle code to interface it. So go to Resource tab, and here comes the particle code sample. Now you can download the code sample as zip file from this very site. From here, the link is provided there. Now you can also have the code from GitHub repository, that is Control Everything Community. Well, now we need some hardware, some accessories, some products along with the sensor, and make some connections so that we can make this sensor working. This here is our sensor LSM330, which we are going to be setting up. In addition to this, we need a particle photon, which you are able to see on my screen. Now, to provide the solution of connections among the sensor and the particle photon, and to further make it a lot easier, and for the other I2C devices connection, we need this I2C shield. This is available on the website controleverything.com, and gently place over the particle photon over the I2C shield to make this connection. Now we need to make a connection among the sensor and the I2C shield, and the binding factor is this connecting cable. Make this connection among the sensor and the cable, and while making this connection, make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and similarly we have to follow this rule for the I2C shield. Hence we are done with this connection. Last, we need to power up our particle photon, and in the picture we can see a micro USB cable. Gently put it over the power jack and hence light it up. Then we have to check for the particle code. We need to interface with our sensor. Let's have a look over that. So now we have set up the hardware required for the interfacing. Now the next thing we are going to do is to interface the sensor with the particle code, and for that we have to visit the website and log in there, github.com, as you can see on my screen, and here we have to search for Control Everything Community, which is the official repository for controleverything.com. Now here the sensor is LSM330, and here we go. As you can see, it's a 3D accelerometer and gyroscope. Now this is the code, particle code we are looking forward to explore. But before that, let's have a look over the instructions we need to follow. First of all, we have to log into a particle photon and set up the device, and this link. Let's have a look over this link as for better clarifications. This is the link which will help us to set up our device and the connections. Yeah, here it comes. This is the procedure you have to follow to connect your device over the USB, and all the relevant information, the commands are given here. You can set up your photon there. Now, in the next instruction, we have to download the code. You can git pull also. Now, we have to go to the online ID and copy the code there. And build.particle.io is the link that you happens to check. Now, it's opening, as you can see. Yeah. It came there. Now here you can name the sensor, and here you have to paste the entire code. Now you can save it here also. Last but not the least, the last instruction is that we have to verify and flash the code on the particle photon, and the code output will be provided on the dashboard, similarly like on the serial monitor. So let's have a look over the dashboard for the better clarifications. Now yeah, it got there. As you can see, the result will be there. So we are done with the instructions, which you have to follow carefully before proceeding to the code. Now let's have a look over the code. Here comes the particle code. It's a .iNEMO extension file. The first thing you notice in the code that we have included libraries application.h and spark wiring I2C.h, and all the applications functions are being included along with that. Now the address of the sensor for gyroscope is 0x6A, and for the address of accelerometer it's 0x1D. So it's a dual address sensor, and these are some of the variables we have initialized here. In the void setter function we have done the same, initialized some of the variables as you can see. Now we have initialized I2C communication as master and initialized serial communication with the baud rate equal to 9600. Next, here comes the writing section part. We have selected the control register 1 having address 0x20, and here we have enabled X, Y and Z axis. Power mode is on, output data rate is 95 Hz, and the writing command is 0x0. In the next writing section, we have selected control register 1 again. Its address is 0x20, X, Y, Z are enabled, power mode is on, output data rate equal to 100 Hz. The command for that is 0x67. So we are done with the writing section. Now here comes another part, that is void loop. Here we have the reading part. Here we have the data selection from the register, that is 40, which is the decimal equivalent. Now here we have run the for loop function, which runs 6 times, and we have read and requested 1 byte each, and total 6 bytes of data being read. So it's a gyroscopic data we are reading. After that, values are being converted for the gyroscopic, which are according to the data sheet for the LSM330. Now in the second part for this reading section, we have the data reading and request for the accelerometer. Data register is 40, as you can see, decimal equivalent. We have requested and read 6 bytes of acceleration data, as you can see, and also here comes the conversion of acceleration data for X, Y and Z axis. Similarly, we have proceeded in the gyroscopic methods. Now we are done with this calculation. After that, at the very end of our code, we have the output data displayed on the dashboard, and we have formatted it, and the X axis rotation along with Y axis and Z axis is being displayed here. After that, there is a delay, and then we have the acceleration for X, Y and Z axis. So it's a raw value of all the 3 axes for the rotation and the acceleration. So this is how a generalized code, a simple code is being displayed for LSM330 for the particle function. So why not we have a look over the working and see how it works. Well, this is the interesting part, which is the practicality of the particle code, and let's have it. So first of all, the first step is to copy this entire particle code, and now open up the build terminal we have discussed earlier. Here, that's correct. And here we have to create a new file, LSM330, and here paste the entire code and save the code. Now verify and compile the code. It's been compiled and it's good. Now flash the code. While flashing the code, we have to check for the magenta flash, which will confirm that code is authenticated and good to go. Now just now we have the magenta flash and it's successful, and the notification you can see at the bottom of the code. So now we have to check for the output on the dashboard. So open it up, and here in the user logs. So you can see the output for the rotational X, Y and Z axis, and along with the acceleration in X, Y and Z axis. Now as you can see, the values are almost stable, which says that there is no motion in the sensor. Now when I move or rotate the sensor, you can see the changes in acceleration value and the rotational value for the 3 perpendicular axes, that are X, Y and Z. Now as you can see, we have the rotational values, it's continuously changing as I'm moving the sensor. That's correct. Now this is how the code works along with the sensor. Now what do we require is our applications, benefits and the features of the sensor LSM330. You can see the LSM330 is a system in package featuring a 3D digital accelerometer with 2 embedded state machines that can be programmed to implement autonomous applications and a 3D digital gyroscope. The accelerometer and gyroscope sensors can be either activated or separately put in power down sleep mode for applications optimized for power saving, and these include GPIS navigation systems, impact recognition and logging, gaming and virtual reality input devices, intelligent power saving for handheld devices, and a lot more. This sensor is available on this very site, and you can purchase it from here, and the relevant code is available on this very site. You go to resource tab and you can get it down there. Now you can also get the code from GitHub repository, that is Control Everything community. So I just want to make it clear that in case if you are in a kind of thought that you are left without fully understanding any part in this video till now, you can have your queries on controleverything.com, and you can post your comments, your queries also on the community page. Now, if you want to check some articles, blogs relevant to this video, you can have a look over instructables.com. And if you want to subscribe video tutorials like these, you can go to our YouTube channel. I hope you found this video useful, and I have a lot more projects coming on my way on the YouTube channel also. So till then, you enjoy yourself, and thanks for watching.